Good morning. I guess it's afternoon now. My name is Mira Kelly-Fair. I use she, her pronouns, and I'm a student at Boston University. This semester, I was in Mike Dietz' class where we were working on our NEON forecast in regards to phenology. And today I wanted to talk to you about the Kalman filter a little bit. This was one of the parts that I found the most interesting of what we were looking at, just because it was something I hadn't really considered before, and I think gives a really good idea of how your forecast works and ways to improve upon it iteratively. So I'm going to share my screen. Alrighty. So as I said, I was in one of the groups that was doing the phenology forecasting. These are my other group members. Just wanted to acknowledge them because I really couldn't have done it without them this semester. So in this, I'm just going to go over kind of basically what we were looking at and then really getting into the Kalman filter itself. So we're looking at GCC, green up, phenology, and what that is if you were to take an image of part of a forest and you were to look at the ratio of green to red, green, and blue pixels in a photo, that gives you an idea of how your area is greening up, and this is a common measurement around the world. So this was the data sources that we used, pretty much what everyone else was using, so I'm not going to go super far in depth on that. You all know it at this point. And we ended up doing a very simple final model. We wanted to run it over all 8 sites that we had access to, so we kept our model very simple since this was all of our first time doing this, and really just used temperature as our variable, which, looking back, potentially wasn't the best model. We at the end started considering another model whereby we predicted our forecast off of what had happened last year, which may have been more helpful. And this was how our initial ensemble forecast ended up looking like, so you can see the different parts and how they played into it. Now, what is a Kalman filter? It's something that we use to compare our predicted GCC values to our observed GCC values. As we were going through this project, we were making predictions, and then we were getting the results of those predictions. And it then would assimilate the temperature data, which was what we were using to predict our GCC, to iteratively predict GCC. So to use that as a way to make a better forecast into the future, and on and on and on. So these are the 8 main sites that we were looking at. You can see them here. So these areas not only ranged across the country, but also in regards to where they were at the time that this was done. So this is from mid-April, and I want to just point out a few things about it. So the Kalman filter that we did had 16 time steps to it. So each one, it was predicting out 16 days into the future. So for example, this one would be our day 1, so 16 days from time 0 here, and it would be predicting out 16 days into the future what we expected to see. And then it would take into account the next day and compare and continue on in that manner. You'll notice that on the last ones, we've got these blocky days, and I did this on purpose. So I wanted to show that if you haven't yet reached a day yet in the Kalman filter, it kind of will just make a blocky marking off of inside the confidence intervals for what you're supposed to predict. So I should have said that earlier. These shadowed areas are the confidence intervals. This is the mean right in there of how we expect the GCC to rise. And then the purple points are the actual observed values. Now you may notice that there's a lot of differences here. So for example, in Dela, it keeps predicting that it's going to increase, but in fact, we see a minor decrease. In BART, it pretty much stays within the confidence intervals, but there's not really an increase at all. Whereas in GRSM, we get to see that increase. It's staying within the confidence intervals. This was kind of what we were hoping they would all look like. And there's a very clear reason for why we didn't see that. And that has to do with the fact that different places green up at different times. So our results were most accurate during and before green up. So this is the Harvard Forest. It's located in Massachusetts. And so during April, it hadn't greened up yet. So this is actually just kind of like our winter standard of no green up. If we compare that to Dead Lakes, Alabama, which had already hit peak greenness by mid-April, the temperatures are still increasing, which is why our model is predicting that GCC is going to go up, but it's already reached that peak, so it's actually not rising at all. And finally, I wanted to show this one, which shows that this was at a time when greenness was actually happening. So we're seeing that this is pretty accurate. Greenness is expected to go up a little bit with each of these. And we've got our confidence intervals that for the most part it stays within. The exception being this dot, which as you can see is a weird downturn that we don't see throughout the entirety of the thing. So these were kind of our general results. This did lead us to consider maybe doing a different type of model in the future, since it was only able to predict the greening up itself, but not after green up. Whereas if we'd done a model that was like, we predict that it will be the exact same as whatever happened on April 15th last year, we probably would have avoided that. So that's my presentation, short and sweet, just a little bit more about how we use the Kalman filter for my group. And I'm excited to answer any questions that y'all might have. Thanks so much.